Almost every scraper you see in a tutorial works exactly once. It runs on the presenter's machine, it pulls the data, the table looks clean, and everyone nods. Then you build your own version. It works for a day, and the first quiet morning, when nobody is watching it, quietly falls over. The site changed a class name, the page started loading content with JavaScript, you got rate limited, and the response came back as a block page instead of data. I have built a fair number of these systems now, the kind that actually feed a real pipeline every single day, and I want to walk through what it really takes to make a scraper that runs itself, rather than one that works once in a demo. Let me start with what the system actually does, because the scraping part is genuinely the smallest piece of it. I have a loop that runs on a schedule. It fetches a set of pages, pulls structured data out of them, stores that data in a database, checks whether each item is something it has already seen, and only acts on the new ones. When something new and interesting shows up, it tells me. That is the whole shape of it. Fetch, parse, store, dedupe, notify. Notice that artificial intelligence is not in that core loop at all. The AI only shows up at the edges, on the messy pages where plain parsing falls apart, and I will get to exactly where that line sits. Here is the part nobody tells you when you start. Fetching the page is the easy 15%. I use plain HTTP requests for most of it, a normal library that asks for a URL and gets back the raw HTML. For the simple sites, that is all you need. The page comes back, the data is right there in the markup, and a parser can walk it. The trouble starts when a site decides not to put the data in the HTML at all. A lot of modern pages send you an almost empty shell and then load the real content with JavaScript after the fact. A plain request sees the empty shell and nothing else. For those, you either find the underlying data request the page itself makes, which is usually a clean little JSON endpoint hiding behind the scenes, or you fall back to driving a real browser in the background, which is slower and heavier and breaks more often. I reach for the hidden endpoint first every single time, because driving a full browser to scrape one number is like renting a truck to carry a letter. Let me give you a concrete example of how that hidden endpoint trick works, because it is the single biggest time saver I know, and almost nobody starting out reaches for it. Say you open a page in your browser, and the listings you want appear a second after the page loads, clearly fetched separately. Open the browser's developer tools, watch the network tab while the page loads, and you will usually spot a request the page made to fetch that data, and the response to it is clean structured data, already in the exact shape the page uses to draw itself. That response is what you want. Instead of parsing the messy rendered page, you call that same endpoint directly and get clean data with no parsing at all. It is faster, it breaks less often because data endpoints change less than visual layouts, and it sidesteps the whole problem of JavaScript rendered content. I check for this on every news source before I write a single line of parsing, because when it is available, it turns a hard scrape into an easy one. The next reality is parsing, and this is where most homemade scrapers rot. You write a selector that grabs the price, or the title, or the date, and it works perfectly against today's version of the page. Then 3 weeks later, the site ships a redesign. The structure shifts, your selector grabs nothing, or grabs the wrong thing, and your scraper keeps running happily while collecting garbage. That last part is the dangerous bit. A scraper that crashes loudly is annoying but honest. A scraper that keeps running while silently storing wrong data is a real problem, because by the time you notice, you have a database full of nonsense, so the parsing layer needs to be suspicious of itself. If the field it expects is missing, it should not store a blank and move on. It should flag that something looks wrong and tell me. I would rather get one false alarm a week than discover a month of bad data after the fact. Now the database, which is the part people skip and then regret. When I first started doing this, I would just dump results into a text file or a spreadsheet. That works until you have run the scrape 100 times and you have no idea which items you have already seen. The whole point of an automated scraper is that it runs over and over, and each run mostly sees the same things it saw last time, plus a few new ones. You need a way to tell new from old, and that is what the database is for. Every item gets a stable identifier, usually built from the fields that make it unique. Before storing anything, The system checks whether that identifier already exists. If it does, skip it. If it does not, it is new. Store it and flag it for attention. That one check, the deduplication step, is what turns a noisy scrape that screams about everything every run into a quiet system that only speaks up when something genuinely new appears. Let me talk about getting blocked, because if you scrape anything at any real volume, you will run into it. Sites do not love being scraped, and many of them have defenses. If you hammer a site with 100 requests a second from one address, you will get rate limited or blocked, and you will deserve it. The honest answer here is to be polite. Space your requests out, add a delay between them. Do not request more often than you actually need the data. If a site updates once a day, scraping it once an hour is just rude and gets you nowhere faster. I also set a normal user agent so my requests look like a regular browser rather than an anonymous script. And I respect when a site says it does not want to be crawled. I am not going to pretend there are no gray areas in scraping, because there are. But the practical truth is that most of the blocking people complain about is self-inflicted from being greedy with request volume. Retries are the next layer, and this is straight out of every reliable automation. The network is not perfect. A request will sometimes fail for reasons that have nothing to do with you. A momentary blip, a server that was busy for a second, a connection that dropped. Without retries, every one of those tiny hiccups looks like a real failure and your run is incomplete. So a failed fetch waits a short moment and tries again, 2 or 3 times, with a growing gap between attempts. Most transient failures clear on the second try. The ones that do not are probably real. A page that genuinely moved or a site that is genuinely down, and those should be logged clearly rather than retried forever. You do not want a broken scrape pounding a dead site 500 times in a row. Now the scheduling. Because a scraper that you have to remember to run is not a system, it is a chore. Mine runs on a schedule with no input from me. On this Windows machine, that means a registered scheduled task. On a Linux server, it would be a cron entry. The tool does not matter. What matters is that the job fires at the right time whether I am awake, asleep, or away for the week. And that if it stops running, I find out from an alert rather than from noticing the data went stale. Once a scrape is on a schedule and reporting on itself, it leaves my head completely. I do not think about it. It just runs, and it tells me when something new shows up or when something broke. So where does the AI actually come in, since I promised it was only at the edges? Here is the honest division of labor. Fetching pages, scheduling runs, deduplicating against the database, retrying failures, none of that needs a language model. And putting one there would just make everything slower and more expensive for no benefit. Where AI earns its place is the messy, unstructured pages. Some sources do not give you a clean table. They give you a paragraph of free text that happens to contain the 3 facts you want buried inside prose. Writing brittle rules to extract structured fields from loose human writing is miserable and breaks constantly. Handing that paragraph to a language model and asking it to pull out the specific fields as clean structured data is exactly the kind of thing it is good at. So on those messy sources, the scraper fetches the raw text the normal way, and then a small AI step turns the mess into structure. That is the only place the model touches the pipeline. And that AI step comes with its own honest trade-offs, which I want to be straight about. It is slower than a plain parser because it is a network call to a model instead of a local string operation. It costs money because I am using a metered API for that step, and every page I clean costs a fraction of a cent that adds up over thousands of pages. And it is not perfectly reliable. A model can misread a field or hallucinate a value that was never on the page, so I do not blindly trust it. The extracted fields get sanity checked. A price should be a number in a sensible range. A date should parse as a real date. If the model returns something that fails those checks, the item gets flagged for me to look at rather than stored as truth. The AI does the hard reading. The boring validation code keeps it honest. Let me also talk about notifications, because the notify step is what turns a scraper from a thing that fills a database into a thing that actually serves you. A pile of new rows in a database does nothing for you if you never look at it. So when the scrape finds something genuinely new and worth knowing about, it tells me on a channel I actually watch. For me, that is a message to myself. the kind of alert that lands on my phone with just a few new items and nothing else. The key word there is genuinely new, which is exactly why the deduplication step matters so much. Without dedupe, every run would notify me about everything it saw, the same 100 items over and over, and I would mute it within a day. With dedupe, the notification only fires for the handful of things that are actually new since last time, which means when my phone buzzes, it means something. A notification you can trust to only fire on real news is worth 10 dashboards you never open. I should be honest about maintenance too, because this is the cost that never appears in a tutorial. A scraper is not a thing you build and forget. Sites change, and when they change, your parser breaks and you go fix it. Across all the sources I scrape, something breaks every few weeks. It is rarely a big fix, usually a selector to update or an endpoint that moved, but it is ongoing work and you should go in expecting it rather than being surprised by it. The thing that makes this bearable is exactly the suspicious parsing I described. Because my parser flags itself when a field goes missing, instead of silently storing blanks, I find out a source broke within a run or two, not a month later. The maintenance is real, but good design makes it a quick known chore instead of a painful archaeology dig through a database of corrupted data. The deeper lesson from building these is that the scraper is the part that feels like the project, and it is the part that matters least. The fetch and parse code is maybe a day of work. The system around it, the database that tracks what is new, the schedule that fires it reliably, the retries that survive a blip, the validation that catches bad data before it lands, the alerts that tell you when something broke. That is where the real engineering lives, and that is what separates a thing that runs itself from a thing that worked once in a demo. I have rebuilt the scraping core of these systems many times as sites change. I have almost never had to touch the system around it because that part was built to survive the scraper breaking. If I were giving one piece of advice to someone starting their first real scraping project, it would be this. Assume the page you are scraping will change without warning, and build everything around that assumption. Do not trust that today's structure is tomorrow's structure. Make your parser suspicious, make your storage check for what is new, make your runs report on themselves, and put a human in the loop for anything that looks off. A scraper built that way bends when a site changes instead of silently lying to you. A scraper built to assume nothing ever changes is a time bomb with a database attached. That is the honest version of building a scraping and automation system that actually runs itself. The fetching is easy, the AI is a small clever helper at the edges, and the unglamorous plumbing around it is the whole job. If you like real working systems explained with their honest trade-offs instead of a clean demo that falls apart the moment you try it yourself, that is the kind of thing I do here. So subscribe and follow along. Thanks for watching, and I will see you in the next one.